Hello, the topic of this section is about error detection. Error detecting codes only include enough data to let the receiver to determine whether the data is faulty or not. If the error rate of the physical link is much lower, error detection and the retransmission is usually more efficient, such like in the network with copper wire or fiber, where the error rate is relatively low. In this section, we will introduce an approach for error detection, and this is called polynomial code. It is also known as a CRC method, which is short for cyclic redundancy check. Based upon treating bit streams as representations of polynomials with coefficients of 0 and 1, we can convert any bit stream to polynomials. For example, in this case, we have a bit stream 1, 1, 0, 0, 0, 1. It can be converted to a 5-degree 6-term polynomial. That is 1 by x power 5 plus 1 by x power 4 plus 1. Polynomial arithmetic is done modulo 2. So both adding or subtraction are identical to exclusive OR. So when we do addition or subtraction, we just need to do exclusive OR. So here comes the basic idea of CRC method, of the polynomial code method. The sender and the receiver need to agree upon a generator polynomial first. We call it Gx. So that should be done in advance. So when the sender tries to send out a message, the sender appends a checksum to the end of the frame in such a way that a polynomial represented by the checksum frame is divisible by Gx. When the receiver gets the frame, it tries to divide it by the same Gx, because Gx is a polynomial the receiver and the sender gets agreement in advance. If there is a remainder, there must have been something wrong. There must have some error. And a retransmission will be required because in theory, if everything goes fine, the checksum frame should be divisible by Gx. So now we try to think about how we do the checksum, how we make sure the checksum frame can be divisible by Gx. So now we are going to explain the algorithm for computing checksum. Let R be the degree of Gx. So then the sender appends R0 bits to the low order end of the frame. So it now contains M plus R bits and corresponds to the polynomial x powers R multiplied by the mx. Divide the bit stream corresponding to Gx into the bit stream corresponding to x powers R by mx using modulo 2 division. And then subtract the remainder, which is always R or fewer than R bits. So we subtract this remainder from the bit stream corresponding to x powers R mx using modulo 2 subtraction. Then we can make sure the result is the checksum frame to be transmitted, and that checksum frame can be guaranteed to be divisible by Gx. So we call it the frame transmitted, we call it as polynomial Tx. So in the end of this section, we have one question for you to try to say whether you have already mastered the algorithm of CRC. The question is, if the message stream given is 1101011011. The generator Gx equals to x power 4 plus x plus 1. So could you please try to figure out the CRC code that checksum the code to be transmitted? That's it for this section. Thank you very much.